Just waiting for the attendee count to finish climbing after we've started. Okay, so the logistics are exactly the same as before. So we will be recording the sessions and sharing the videos in the next day or 4. Questions in the chat and in the Q&A tool are very much welcome as we go. I will try to pick them up as we talk through so that they're near to the topic we're talking about. I will also ask the questions at the end if there's anything left over, if there's anything you wanted to know that we didn't cover. But yes, you're very, very welcome to ask questions as we go. The slides are available. It's the same shared folder that you used last week if it's auto-completing in your browsers, and if not, I can see it is in the chat for you. So it's a slightly more mixed up session this week. So last week was all a kind of narrative of the stages of making a patch. We're now going to dip in and out of different things, things like philosophy of thinking like a maintainer and how to align your interest with theirs, tools and techniques, things like that. So we will move on to talking with Upstream. So I've got that slide. Yeah, so talking with Upstream is quite simple in the main sense, is that ultimately the primary activity you will be doing is communicating by email. It almost always means sending messages to one or more mailing lists, plus the to and CC to bring the actual maintainers and reviewers in. We talked about the maintainers file last week. That's in the source tree. It's to help you figure out who you should address your emails to. If you have kicking off starting questions that don't have patches associated with it, you can read maintainers manually to figure out which mailing lists to connect to. The nature of a mailing list, rather obviously, is it's a multi-way conversation. It's not a specific talk with a specific maintainer. Your email conversations will be with maintainers, and there may be more than one for each subsystem, reviewers for the subsystem, other developers that work in the subsystem, and anybody else who finds that aspect of the kernel interesting, which can include tech journalists, particularly when you work on high-profile things like graphics drivers. So the other thing to observe is that maintainers in one subsystem will also be engaged kernel developers and may well be developers in other subsystems. So you may see similar people pop up just because they're active in the same ecosystem. They won't always be in maintainer roles, but they'll still be involved and influential. So if you just have a question of how to get started, or what is the best way to structure this driver, or even which is the driver I should use as a template because it is the best maintained or the most recent, you could ask that. You might not get replies to maintainers, but it will also be picked up by reviewers and developers and the other people in the mailing list, and they will also be able to offer you information to get started. So the sort of primary way to start the engagement, give some clues as to your motivation. If you are trying to enable a piece of hardware, give a short summary of not the fundamental, not the fine details of it, but I have a hardware random number generator. It reads from a register. I have a hardware random number generator. It is accessed in a particular way, or it receives its numbers in a particular way. So if you need to ask for that advice on the best way to start, or some question you have before you start coding, you can do that. Quite often I find that I prefer to write a patch to the point where it illustrates the question and send it as an RFC. That's my personal preference. But it's something we didn't really touch on last week. Developers who hang out on mailing lists are doing it because they quite like hanging out on mailing lists and are happy to give advice. So there usually are people there who are interested in what you say if you've got and found the correct mailing list. As you said, my personal preference is questions illustrated with code, which I tend to send as patches and RFC. In terms of manners, a lot of the people that you converse with when doing upstreaming are not there to serve you. They are possibly not even paid to talk to you. Even some of the maintainers who talk to you, who work for a company, do parts of that maintainership and advice and information out of hours. They're not necessarily directly measured at their review time by the amount of replies they send to the mailing list to help other developers. So be sure to be, at least acknowledge contributions, and where somebody says something that's particularly useful, you should be saying, "Oh, thanks, that makes sense." It is, as we discussed last week, a social activity, and behaving well on the mailing list is a good part of maintaining social connections with people. We've already discussed that there is no point in discussing your schedule with the upstream. In the simplest case, they will simply not engage with you about it. Or they might challenge it and say, well, that's not our problem, and things like that. There's no reason to discuss your schedule on the mailing list because it's unlikely to create a good outcome. It does follow that you should, once you've been assigned to a subsystem, you should start working both how it operates technically and socially as early as you can. And one final observation about comments and questions is there's two things that can be going on. One is that if you start writing a driver, you get pulled off for 4 other activities and then come back to it. The expectations of upstream may have changed since you last spoke or asked a question. The other is, of course, the questions will be answered by multiple parties, developers, maintainers, reviewers. They might not all agree with each other. And it's one of the responsibilities you have when upstreaming is to figure out what's good advice, what advice you need to challenge. Most of the time you can take all the advice because it doesn't contradict itself. When you get advice that is contradictory, the simplest technique is to say, I used to have it work like this, but I changed it to this because of this email. And then they will discuss and engage with each other to some extent to create a resolution. In terms of mailing list, just the sort of culture you expect to see on mailing lists. Firstly, we do have a strong culture in Linux of public mailing lists, to the extent that the vast majority of mailing lists are actually open post, so that you do not have to be a member of the mailing list to post to it. And the reason for that is it allows people who are clustered around particular subsystems and technologies to take part in it. Everybody who is interested in it can participate. And by being public, all participants effectively are observed, and if they act unreasonably, it negatively affects their reputation. So it actually tends to encourage good behavior. So the people who do reply are usually offering you useful, helpful ideas and comments, either based on their own experience and what comments get given to them, in which case they're simply kind of passing on the culture and expectations, or if they're maintainers and going into the detailed design, they will be pushing for the direction they think things should be done. People who supply ideas and comments, as I say, get noticed in the community, and it makes their journey in other spaces a little bit easier sometimes. I put this in brackets because I'm not an expert in any other culture, if I'm honest, but it is very much Western culture on the mailing list, which tends to manifest itself as a strong focus on the technology and not on words to soften things. So it can be very, very direct and very blunt. There is no specific accounting to relationships between people. It is just, this is how it should be done style of communications. To expand more on that, like I say, my cultural knowledge, this particular bullet point was written by somebody living in Taiwan, a Western developer living in Taiwan. He was the one who contributed this particular note. And in general, the mailing list culture is supposed to be polite and professional. People do feel very strongly about some of these areas. The kernel is something that people care deeply about. That can affect their communication, but in general, polite and professional is very much the norm for the mailing list. The other things are somewhat more mechanical. Contributing on the mailing list, there are special rules, well, not special rules, there are manners that we expect people to conform to. And the main manners, which are very different from business email settings, are that the expectation is that all posts to the mailing list are plain text, no HTML. Most mailing list servers will actually prevent you from posting HTML anyway, but everybody you copy on to and CC will still see the email. So in other words, if you are sending a HTML email, the only people who will see the HTML email are the most influential maintainers and not everybody else who might comment on it for you. So it's a very, very important aspect to send plain text email. And the other habit that should be avoided is top posting. So top posting is a mechanism where you place the whole of your message at the very top of your email, and the bulk of the previous email sits below it. That's why it's called top posting. The style that is used on the mailing list is called inline reply, which is where you quote a small piece of the previous message and you react to just that small piece. And I could tell you it's required, which is enough, it is required, but I can also tell you why, and that's because replying in line is better able to gain consensus without having to hold a meeting. The very nature of reply in line is that you are required to react to what the other person has said. It tends then to focus on the places where you have some kind of technical disagreement. So the manner is you delete the text you agree with. Right, so when you do a reply in line, you delete the pieces that you agree with, possibly saying, I'll do all those other things in an act to everything except. But then you focus on where you disagree and you discuss until the disagreement is overcome. So that's why reply in line is pushed so heavily. It's not merely, there's a whimsical thing with the A at the top, and it says because it messes up the normal flow of conversation, and then a Q underneath saying why is top posting bad. But that's not the real kind of essence of what replying in line brings. Replying in line is all about focusing on where you disagree and getting rid of that disagreement, which is very, very important for collaboration online. The final documentation that I should point you to, I've probably moved actually, I think this link will be out of date. So a documentation email clients.txt. I would be near certain that I should have changed the slides there, so let me just double check. I beg your pardon, I should have had this before. I didn't spot this one in time. So it's moved to process email clients.restructured text. I'll get that updated. Process. I'm sure you'll find it either way. You can also find it in the HTML versions of the rendered documentation. It's basically advice on how you can configure certain email clients to meet the plain text rules. So yeah, if you do not follow these rules, any of the rules related to kernel posting and style, then in the best case, it simply means the discussion will be about your email instead of your patch, which is simply counterproductive. And I will restate that kind of golden rule that we had from last week, is that maintainers are the only path. So it is wise to make them as happy as you are able. Okay, so we're going to come back now. So it's moving on from that kind of mailing list approach. As mentioned, there are other things that you can do to talk to Upstream, things like IRC and going to conferences, but they are additions. You can be a very effective Upstream engineer without going to conferences, without joining an IRC, just by emailing, because that is the dominant communication, but there are these additional lubricants on the side. So we're going to go back to the tags now. So the signed off by tag. Ultimately, the signed off by tag has a very, very formal definition, and it is on the screen right now. So what you are signing off when you sign something off by is the developer certificate of origin. That is the document that you are asserting that you have signed and acknowledged. So you've got the boilerplate at the top, but the predominant pair of things you're signing off usually are A and D. So the way this covenant, this certificate works is you're asserting that either A, B, or C are true, and that D is true. That's what you are saying. So you're often saying that the contribution was created in whole or in part by yourself, and that you have the right to submit it under the open source license indicated in the file. So when you are working for a company, the fact that you created it does not mean you own the copyright. It will be a work for hire and it will be owned by your employer. So you are not just asserting that you wrote it, you're also asserting that your employer intends to submit it under the open source license indicated. That's the normal case. There are two additional cases, one of which is you are basing it on somebody else's work, and to the very best of your knowledge, that work was available under the open source license indicated. This is why it's a bit nuanced. Somebody asked a question last week about who has to sign off and everything else. So you certainly can sign off other people's work based on contribution, the idea of B. So yes, you can fully sign off other people's work, although manners and credit to the original authors might prefer you to put something like a co-developed by and ask them if they would like to sign it off as well. But ultimately, if you have got an appropriate license to use it, you can be the sole sign-off. And the third one is to allow you to pass patches unmodified from person to person. This is roughly speaking what maintainers do a lot of the time when they sign things off before they send it to Linus. The contribution was provided directly to me and I have not changed it. So somebody else has already certified to me A, B, or C, and I'm simply passing it on. The fourth clause is essentially a privacy clause. It's observing that your contributions to the project are made in public and will go into the Git history, which is irrevocable, can't be altered. So they're saying that the information you've provided along with the patch, including the fact that you signed it off, will be maintained indefinitely and may be sent to others because that's intrinsic to the nature of how Git works. So D is an important acknowledgement that you do lose a small amount of privacy by contributing publicly, in particular disclosure of your email address, but that you consent to it. A, B, and C are the things that are to assert A, B, or C incorrectly and to be discovered would be hugely, hugely damaging to your reputation. So I don't advise that you consider whether or not this is legal in your jurisdiction. I mean, it has been reviewed by Linux Foundation lawyers, but the legality is actually not the biggest part for you personally as a developer. For you, the fact is if you get this wrong, it is very seriously detrimental to your reputation. So in particular, being sure that you have got the right or permission from your employer to submit to the kernel is very, very important before you make your contributions. Reviewed by, which is what you can do if you're reading other people's code and you want it to be accepted into the kernel. You can provide a reviewed by. In particular, if somebody modifies a driver that you've already upstreamed, it is very much appreciated by maintainers if you provide a reviewed by. Reviewed by also has a formal definition. It is less explicit than the developer certificate of origin. This one's called the reviewer's statement of oversight, and it's basically saying you've carried out a technical review, you believe it improves the kernel, and you believe that it contains no known issues that should prevent it being included. It doesn't mean you've said the patch is perfect. It doesn't mean you've said that it doesn't regress. It means you're saying it's a good improvement to the kernel and you do not know of any issues that would argue against it being included. You can read the other details at your leisure, but those are the key things that you are really asserting to. The section, I mean, it's all valid, it's all true. But those items I've pulled out in bold are the ones that you should kind of internalize as to what you're really saying when you send in a review by. There are then less formal tags. So act by is it acts similar to something like reviewed by, and it's an indication the person who's acted has had a look at the patch and does not object to it being applied. It's an explicit statement that I do not object to this patch being applied. It is mostly used by maintainers to indicate that they have seen it, they would be happy to see it added to the kernel, but for various reasons to do with perhaps the structure of the patch set, they are expecting a different maintainer to apply it. So in that sense, act by is a message between maintainers to say, yeah, this is cool for me, you can apply it. It's very commonly used, like I say, for patch sets that touch multiple subsystems to allow one maintainer to suggest to another maintainer that they should apply it. It's useful for you to get act bys. They are signs of support, but they don't have that same formal role as reviewed by. Reviewed by is a statement that you've put in essentially more work, perhaps, than an act by. Other common tags that will pop up. So CC is an interesting one. CC is one of the few tags where you could put somebody else's name in it without them having taken an action. So clearly you can't do a signed off by with somebody else's name on it. That's entirely inappropriate because it would be asserting that they had made an action that they hadn't. Similarly, you can't do a reviewed by with somebody else's name on it. CC you can add with somebody else's name on it, whether or not they've done it. It's basically a record. If you want to record that you made a patch visible to a developer specifically, particularly if you're asking for a patch to be applied in a different subsystem, to be able to say, look, I've sent it to this person, they haven't responded for the last 2 months. CC is very effective for that, to kind of record, to show that they have the chance to read it. The others are all about credit, really. So co-developed by is a way to record that a patch had multiple authors. So if you've collaborated with another developer and they've agreed that you can send the patch in, you should ask them if they are happy to provide a signed off by. And then if they are, you can add a co-developed by and their signed off by. And co-developed by is simply working around the fact that Git commits cannot have multiple authors in the Git. Git will record exactly one author. So it's a way to record in the text that there were other contributors. Co-developed by is also one that is spelt differently in different communities. So this is a course about the kernel, and there are other similar communities that have similar community norms. I'm thinking of things like QEMU and Zen, and there's several basically projects that have been very heavily, U-boot, yeah, that have all been very heavily influenced by the Linux kernel processes and adopted very similar processes. However, in some of those communities, co-developed by is spelled co-authored by, but the recommended spelling in Linux is co-developed by. Reported by is a way to credit a bug reporter. So if somebody sends in a bug report to say this system doesn't work in this case, then when you send a patch to fix it, you should credit their report in the reported by. And a tested by is a way that other developers or yourself can report the fact that you've done some sort of runtime testing. Suggested by is the final form of credit. Suggested by is if you've done that request for comment or you've asked for help on the mailing list and somebody's given you really good advice that led you to develop a particular patch, you credit that suggestion. You credit the fact that they helped you to get started. And I think the final type of tag that we want to talk about is fixes. So fixes are the simplest mechanism for you to request a backport to the stable kernel. So the stable kernels are maintained with the view that we shall only work with bug fixes. If you want to get a bug fix into the stable kernel, the way you do that is you fix the bug in the upstream kernel and you tag it with fixes. And fixes indicates the first 11 digits of the SHA-1 code where the bug was introduced. So if it was a bug that has always been there in a driver, you find the commit that introduced the driver, and that's the commit you point in fixes. If it is a regression, you can point to the patch that introduces the regression. And the reason to have that identity is that when Greg or one of the other stable maintainers, they basically look at the patches being applied to the mainline kernel and hoover up, they spot all the fixes. They then have a whole bunch of scripts that finds out when the bug was introduced, find out the set of kernels that they need to change, and automatically attempt to backport the patch to the appropriate places. You can read more about fixes in the kernel process documents. It is worth reading because there are ways to describe fixes with limits. Like, although the bug was introduced here, my patch will only backport as far as this version, which is very helpful to stop excessive work from stable maintainers. And there are other things you can learn about the stable kernel as well. So I think it's called Stable Kernel Rules. It's worth reading, but fixes is the best way as a kernel developer that you can contribute changes to the stable kernel. The final thing about tags is there is, again, etiquette associated with the management of tags. So collecting tags here, what I mean is that when you have tags that have been offered by email, then they get added to the patch description. So when a change is applied, if somebody has sent a reviewed by on the mailing list, their expectation is that when the patch is applied to version control, that reviewed by will have been collected, added to the patch description, and become part of the formal record in the kernel. That's what sending in tags means. So that means that when you resend a patch, whether that's a new version of the patch or a resend, then you, as the submitter, are responsible for collecting all the tags in the previous version. That applies to everybody who upstreams. If you send a version 2 patch or a resend patch and people have emailed you with tags, you are responsible for finding out the tags that they have applied and adding them to the patch description before you send it out. It is your responsibility. The only time it's not your responsibility to collect tags is when the maintainer applies. So when the maintainer applies from the mailing list, the maintainer will collect all the tags from the most recent version and add them to the patch. They will not find patches from the previous version because it's not in the mail history. Most maintainers, and you can as well, use automatic tools to collect tags. So collecting tags is an important task. You do have to learn to do it. When you're beginning, you have the capacity to do it by hand because you won't get very many reviewed bys. You can just copy them in and it's fine. If you start sending large numbers of patches and you have to maintain lots of in-flight patches, you might start using automatic tools as well, like Patchwork or B4. So manners and etiquette around tags. Firstly, you don't add tags except CC without permission of the named person. Let's get a D on the named. Or something that is directly equivalent to the tag and in the public record. So suggested by doesn't need somebody to say, please add my suggested by. Suggested by is there is a suggestion that you have followed sent to the public record in the mailing list. Similarly, tested by, most people will give you a formal tested by tag that you can just copy and paste. But if somebody says, I have tested this in this configuration, you could convert that to a tested by. But in general, if somebody sends you that sort of thing, I would tend to reply and say, can I add a tested by? Because if they are generous enough to reply to that with a tested by tag, the automatic tools pick it up and you don't have to do it manually. But yeah, so you can use something that is directly equivalent to the tag, particularly for tested by and suggested by. But in general, you do have to have an explicit action from the other person to add them to a tag. It does follow you are responsible for collecting tags. Do not ignore tags when resending patches. That is a very good way to make particularly maintainers cross. So if I go through a set of 10 patches, I've added reviewed bys to 7 of them and left comments on the last 3. When that patch set comes back to me, it's very, very helpful that I can see which ones I've already reviewed and not end up wasting my time reviewing them again, because I don't necessarily remember 3-4 weeks later when somebody sends a slow resend that they've even done it. So yeah, it can make people very cross if they realize that they're reviewing code again that they've already reviewed and that you have neglected to collect the tags. But there is the corollary. If you make massive changes to a patch that has already received a reviewed by, and rather than doing small changes that have been suggested on the mailing list in the open, you end up doing a significant rewrite of a significant chunk of the driver, you should remove reviewed by and act by tags at that point. So if you make huge invasive changes to an existing patch, acknowledge that it has been reviewed and just say in the changelog that this change is so big, I have not preserved reviewed bys because I didn't think that would be appropriate. So it works both ways. You must collect patches when there are minor changes. You should potentially not collect patches and say why when you make very big changes. So that's all about tags. I hope that kind of cleans up all the questions we took last week in relation to tags. If not, you have the chat and the questions, and I'll pick them up as we go. So the next section we're going to look at is called Thinking Like a Maintainer. And this is simply a reflection of the fact that upstream maintainers have a different job with relation to the kernel than vendor engineers. Particularly in the embedded space, vendor engineers are usually working on product-based kernel trees, and that often involves using older kernel versions. Even the most up-to-date companies tend to focus on the most recent long-term stable kernel. And some companies are really good about chasing the most recent versions of either the kernel or the long-term stable. But ultimately, there is a habit in the embedded industry that once a kernel is complete, it is shipped, and only bug fix work gets done to that tree. That ship is starting to turn now. There are requirements coming, legislative requirements in some jurisdictions, that consumer electronics be made supported for extended periods of time. And the extended periods of time are sufficiently long that some thinkers are taking the view that that mentality from the embedded industry of ship a kernel and keep it in the product until the product expires may no longer be viable. We may expect to see kernel upgrades in the field because maintaining kernel for 6 years is considered to be infeasible by most people. So yeah, there may occasionally be one-off rebases, things like that. I mean, the reason the embedded industry does it is to avoid having to do regression hunting on old products. But ultimately, if the lifespan of those products is increasing, then it becomes worth doing that investment to do the regression hunting. And then the additional thing for classic embedded vendor kernels is when a new product gets updated, it updates to a more recent obsolete kernel, and then they do a full report of the drivers. That is the experience for a lot of embedded kernel developers. And like I say, the world is at a point where we might see some shifts here, but that is a reality for many vendor engineers. And finally, obviously, the vendor engineers only really care about the specific lumps of silicon they have in front of them. The maintainer is going to be very different on that basis. And the best thing I can offer is a quote from the kernel development process. It's basically saying kernel developers usually expect to work on the Linux kernel potentially for the next 20 years. They do fully understand that their employer could change during that time. They don't expect to have the same employer for 20 years. They do expect to work on the same thing for 20 years. That means what they care about most are things like their personal expectations and the viable future of Linux. Those are their personal ambitions. Now, happily, that also often aligns with the goals of their employer, which makes kernel maintainers valuable. But they truly are working to create the very best kernel that they can. That is the goal of almost every kernel maintainer. They are trying to make the best kernel they can, but they don't necessarily have the same definition of best that a vendor engineer might. So this is a pictorial representation of maybe what the vendor engineer believes their kernel is going to be. And I have to say, early versions of these used to have a picture of a 1975 Oldsmobile in this particular slot, which was an old American wooden paneled vehicle. It looked very, very old. And I don't want to compare everybody's modern embedded electronics to a wooden paneled 1970s car. So this is a modern 21st century muscle car. But the maintainer might well have a different view of where the industry is going to be while they are working on the Linux kernel. So what we have here are vehicles of radically different size. There are some very, very small systems, some very large systems, and some car-sized systems. As it happens, I've selected images that are all electric vehicles. And it's not to suggest these are modern and those are old-fashioned. It's that the horizon for where people see the kernel is a few years further ahead than the horizon for vendor developers who have to ship a product in the next 6 months or 12 months. And I don't know what I will do for these diagrams when electric cars become dominant, but that's just the thoughts that you should have in your head. It's to do with the motivations. You are likely to have, if you're working on vendor kernels, slightly shorter term motivations, but a slightly different set of goals. And to work in the upstream, you have to align. It's not because the goals are not incompatible. Time and time again, people are able to work with upstream. The goals are not incompatible, they are simply different, and accepting the difference does a lot for understanding how maintainers are going to react to things. Now, we can get concrete. We can use silly analogies about cars, but we can get concrete as well, which we will do. So ultimately, upstream maintainers have to think about the long term, because once your code is accepted, it will remain in the kernel for a very long time. It is only really when the last pieces of hardware are starting to die off that drivers and code gets removed from the kernel. So I believe it was 486 is making the news for being removed from the kernel, if you think how old a 486 is. So the other thing that upstream maintainers do to simplify their work is they will only accept code that is applicable on the latest Linus tree, or potentially even more recent maintainer trees like -next branches. Not only do they have their own views about the future of the kernel and the kernel quality required, but they also have a strong demand from other maintainers and from Linus to maintain standards. So they are in part motivated by the desire to make the kernel the very best they can. They're also motivated by not wanting to upset other maintainers. And it follows from that when you add code to the kernel for one architecture, it's important it slots into the frameworks in an appropriate way so it doesn't do any harm to any other code in the kernel. So I call that, to some extent, working is not enough, and we'll review the different ways that working is not sufficient. So being as good as another driver in the kernel is not enough. And this is frustrating if you've copied a driver and used it as a template, and then the maintainer picks up on lots of problems in your code that you simply copied from another driver. That's okay. As I said, maintainers' standards and understanding of what is maintainable changes as they gain experience. So being no worse than another driver is not sufficient. Your code is not judged against the worst drivers in the subsystem. Your code is judged against the best drivers in the subsystem, which is why I advise you to read multiple drivers in a subsystem before you make contributions, so you can get a sense for what the best drivers look like in that subsystem, because that is the standard that you will almost certainly be held to be as good as the best code in the subsystem. When it's being reviewed, like I say, maintainers look at your code with slightly different eyes. They're looking for different things. And one of those is that it's not going to give them any trouble over the next few years, that they can understand it, that if somebody says this needs changing, they will be able to make those changes without having to invest huge amounts of work to understand how complex code works. For that reason, quite often changes do need to be made because of that difference in approach. So as soon as you think your code is reviewable at a quality where review makes sense, you should share it as soon as you are able, because there may well be some further journey to go. That doesn't mean take shortcuts and don't make changes that you believe need to be made. But as soon as you're able to share it, you should definitely share it. Works for me is also not enough. In the sense that one of the things maintainers might do, if your driver adds features that look like they would be replicatable on other platforms, you may well be asked to factor pieces of your driver out and put them into the subsystem. So in other words, if your patches have a bunch of code to manage some aspect of a bus that your bus controller is the first one to implement, and therefore you're having to write them yourself, you might well be asked to put them into the subsystem so that competitors can use them. That's because the focus of the maintainer is maintainability, and having a case where 4 different drivers had 4 different implementations of the same features is simply not acceptable to maintainers. It is not maintainable. It makes their life very difficult. So even though that code will be potentially used by competitors, it will still be your responsibility to factor it out for your driver to be accepted. That does come the other way around, of course. Every time your competitors then bug fix that infrastructure that you've written, or optimize it or improve it, you get the benefits of that as well. So you know, these things tend to come round over time. You've joined a kernel because it had so many drivers, some of which were probably written by your competitors in the first place. So it's something you can live with. But yes, you may well be being asked to do a rewrite to make it easier for other people to consume your code. And maintainers on your path, and if that's what they're pushing you to do, you will very likely have to do it. So I've used the sort of 3 slides ending with not enough. You know, working is not sufficient. Being a particular quality that already exists in the kernel is not sufficient, and works for me being insufficient. So ultimately, the best strategy you have is simply patience and acceptance. That's why I talk about thinking like a maintainer. These are things that won't necessarily sit high on your priorities, but will be necessary for upstream kernel to be accepted. The earlier you are in the game, the better or the more able to be patient you can be. As soon as you get to my deadline is this, you are going to struggle because people don't care about your timescales. So starting early is the best way to mitigate both the indifference to timescales and the patience needed if you're doing something very new. And we can, when discussing these kind of complexities, managers point out that almost always the things you're being asked to do are going to improve your solution as well. Either making it more general or maintainable, or hoping to get fixes to it in the future. You can't necessarily see what's going to be the future at the point you're making the changes, but in general, that kind of experience looking at your code improves matters. So that's the other way to help you maintain your patience and gentle acceptance of the changes you have to make. There are cases where you could and should push back, but they're pretty rare. I can't offer you examples. But particularly this one, if the rework you're being asked to do is so huge, you could ask, how can I get help with this? That's far more than I'm capable of offering right now, to see if there is scope for negotiation. But ultimately, it's technical and social influencing, persuade that it's better to apply your patch than to ignore it. And if it brings in a whole bunch of vendor specific stuff, the inclination will be to ignore it. But there are cases you can discuss. Of course you can. The nature of a social process is you can discuss back, counter propose, create some kind of compromise. But when you don't need to argue back, don't argue back, because you resolve things quicker if you do what you're asked rather than enter into long discussions. So that's thinking like a maintainer. And the last thing we'll do before we dive into those tools and techniques are to look at the kernel versioning and release flow. So last week I kind of informally mentioned things like the merge window. And we didn't go too deep at the time into trying to understand what the merge window actually is. So that's what we're going to look at right now, so we can understand how it affects our work as upstream developers. So first, there's a couple of very obvious truths here. Kernel versions have, kernel releases have version numbers. Who would have thought it? So the main two numbers are the ones managed by Linus. So 5.7 is a kernel release made by Linus Torvalds, as will be 6.1 when it comes out. So the first two numbers are generally indications of which Linus kernel it started from. And then we have a third number, which is the number of stable updates. So as soon as Linus releases a kernel, he will then start work on the next kernel. And it will become a release, become a Git tree, then it will become a release candidate, and then it will become the next kernel. So the stable kernel is actually the most recently released kernel, so currently 6.0. It's not a long-term stable kernel, it's just a stable kernel. It will only be stable until the next Linus release comes out. So in the gap, while the kernel developers, there's a 10-week gap roughly between kernel releases, and in that 10-week gap, while the kernel developers are working on new features, the most recent stable kernel will receive bug fixes and represents the best recommended kernel for users to use. That's the recommendation of the kernel community, is running the latest stable kernel should be the best kernel the community has produced with the least bugs and the bugs that have been applied to get backported to fix it. That's roughly what you're claiming to give people with the stable kernel. Some kernels, 5.15, 5.10, 4.9, 4, and so on. Lots of different version numbers. Get what's called long-term support. And long-term support is basically an agreement to continue to backport patches to a kernel that is older than stable. And they will tend to get backports for multiple years. Historically, they used to get 2. Currently, some of them are getting support for 4 years. It's not guaranteed that a long-term stable kernel will move out of the 2-year window into the 4-year window, but it is quite common at the moment. And the numbers can get very large. So 4.4, which has now been removed from long-term stable, it's no longer a long-term stable kernel, it's now an obsolete kernel. But it did have 302 releases during its life cycle. So long-term stable kernels do get a significant amount of driver churn and changes. Long-term stable kernels are of no interest whatsoever to people who are upstreaming. In fact, neither are stable kernels. The only patches that are going to be accepted into the kernel are going to go against the latest kernel. There are some tiny exceptions for patches that fixed bugs in the mainline kernel without realizing that they'd fixed the bug, in which case you might be able to extract the bug fix from that thing and submit it for a long-term stable to cure regression. That's mentioned in the stable kernel process, and it's quite an exotic and unusual case. Normally you fix upstream and everything backports. As an example, the Qualcomm landing team, which is a team in Lenaro, sponsored by Qualcomm, runs trees based on those long-term stable trees. The trees they release for others to build on, they do upstream first. They're all upstream first developers, but then their work is backported to the long-term stable trees. So you end up with a long-term stable release plus some driver hardware enablement. And that's a very common pattern for embedded work. If you upstream first and backport, that becomes a good basis for product trees. So that's kernel versioning. I beg your pardon. So you can see the strange anomaly at the moment that some older kernels have longer sunset times than the newer kernels. And that's precisely the thing I alluded to before, that the default is a 2-year support period. It is often extended to a 4-year support period. And the result of that is usually one of the 4-year long-term stable kernels actually has a later sunset date than the newer long-term stable, which is still only in the 2-year window. The other main cycle, so that's the kind of how long-term stable kernels are maintained. From the upstreaming point of view, the thing that really matters is this kernel release and release candidate cycle. So roughly 10 weeks. It is variable. So the reason it's variable is because when you get to around about week 8, week 9, what Linus is doing is looking at the amount of bug fixes that are happening. And if he feels that the bug fixing has dried up, there's just not very many bugs in this release, he might release a week early. If he's seeing lots and lots of bug fixes, more so than usual in release candidates 7 and 8, he will take that as a sign that we need release candidate 9 to think. And sometimes there's just a holiday, whether it's Linus's personal holiday or a large internationally recognized holiday. Then the release candidates will move around a tiny bit to accommodate that time when most maintainers aren't working on the kernel anyway. But the structure of a release cycle is, so at the moment, Linus cuts a release when he releases a 2-digit kernel, 6.1. The merge window for 6.2 will open. The merge window for 6.2 will open. During that time, week 1 and 2, maintainers will send all the contributions and new features that they accumulated during the previous kernel cycle and send them to Linus. As an upstream developer, the merge window is only for maintainers to send already tested code to Linus. So when 6.1 is released, it is essentially already too late for new features to be proposed for 6.2 because they are already in the kernel right now. You know, the kernel, they're already applied by maintainers in maintainer kernels. They'll be merged into Linux Next. They're already being tested right now. So although 6.1 hasn't been released yet, it's too late to add new features to 6.2. And the other thing is, during merge windows, maintainers are very busy and most don't review code. So when I mentioned last week about resends, some developers, some maintainers will be very unhappy if you were to say resend at the beginning of week, so send at the beginning of week 1 and then resend at the beginning of week 3, because they view the merge window as a time when they're sending code to Linus and they're not going to spend a lot of time reviewing patches. So the best time for you to send patches is RC1. If you've been developing them, then if you release them at RC1, then they have lots and lots of lots and lots of time during these kind of release candidates where they can review your code, apply it to a pre-development tree, usually called some subsystem minus next. They can test and learn everything else. So if you submit basically in the first sort of week 3, 4, 5 are the best kind of window for you to send code and have it reviewed, because then there's time for reviews to happen, you to fix it, another review, fix it, and you've actually got a shot of hitting the next window. The other thing that will happen, so maintainers are quite open to patches through this kind of window RC1 to RC5. If you send in good patches, adding new features or adding new drivers, if they're happy with them, there's a very good shot they'll get applied. Once you get to kind of RC5, RC6, depending on the maintainer, maybe RC7, maintainers start to close their trees and they don't accept new features because they're going to spend RC7 and RC8 running a barrage of tests against their subsystem, so that when the next release happens and the next merge window opens, they're ready to take it. So what this basically means is the kernel you're targeting is always quite a long way ahead. You know, when you submit a patch in week 3, what you're targeting is something that lands not in this release, but in the merge window that sits here and the release after that. So we say the kernel is coming along every 10 weeks, but you're usually shooting for a kernel at least 12 weeks in the future and sometimes 18 weeks in the future. So I hope that makes sense. The idea is that, you know, if you miss a release, you miss a release, you can take the next one. But maintainers will react to patches differently depending on where they are in the kernel release cycle. So it's worth you understanding where we are in the kernel release cycle. You can always see where you are in the kernel release cycle because it's on kernel.org, where we should see now we're currently in 6.1 RC8. So we are rather expecting to get 6.1 released very shortly. There will then, by the looks of it, be a possibly slightly shorter merge window because of Christmas. It might close early. And then we'll go through the usual release candidate cycles again. So that's the kernel release cycle. And the key thing as a contributor is recognizing the merge window is a time for maintainers to send code to Linus. And as a patch contributor, you know, your golden time, your best time is, you know, for a new patch. Obviously, for a patch that you've had reviewed several times over, just keep going and keep going. So you can ignore the merge window to some extent. If you don't care which kernel it lands in, just share the patches and wait for reviews and so on and so forth. But if you're trying to schedule and prioritize activities, particularly if you've got kernel development and non-kernel development tasks, then doing some development during the merge window so that you're able to share it in week 3 of that cycle, it is a way to be most efficiently aligned upstream. So I hope that makes sense. So this is actually just restating what I was saying verbally a moment ago, that maintainers typically only accept code between kind of RC1 and maybe RC5.6. At RC7 plus, it tends to only be fixes accepted. So I've been careful to say new features over and over again here, new features, new drivers over and over again during this thing. Bug fixes are acceptable at any time. And if you submit a bug fix in week 9 for a live bug in the kernel, you know, the maintainer may well pick it up very quickly and get it to Linus within days. As soon as it passes basic testing and code review, if it's a bug fix, none of the release cycle stuff applies to bug fixes. This is what applies to new features and new drivers. But as upstreamers, a lot of the time what you're judged by is what drivers you can land in the kernel. So that's the release cycle is actually more dominant for driver developers, whereas maintainers and people who are fixing bugs also have to deal with bug fixes jumping the queue, if you see what I mean. So summary being, kernels come along every 3 months-ish, maybe 10 weeks. The merge window itself is typically 2 weeks. And when to send patches. So fixes can be sent anytime. Fixes are always welcome. And particularly if you spelt it well, so you can tell that it's a fix, maintainers can pick them up and recognize them. If the maintainer thinks it's a low priority fix, it is a habit of some maintainers to absorb the fixes and treat them like new code. That's up to them to some extent. It's slightly controversial because some maintainers feel very strongly that fixes should always be fixes. And it does depend on the fix. I mean, if it's just using a, well, I suppose the difference in a fix and a cleanup. So cleanup, where you are using better API, will never ever jump the queue. So some maintainers will see a fix to an error path that is very improbable. So if it's a error path connected to memory exhaustion, yeah, the fix should be applied, but they may view it as a cleanup because it's very hard to trigger that error path. So, but you can still send it as a fix. It's up to the maintainer to decide when they apply it. But anyways, for new codes, cleanups, and these very minor fixes, it does depend on the maintainer, but typically the best time to be sending them is the 5 or 6 weeks after the merge window closes. And like I say, you can always look on kernel.org to find out whether the merge window is currently open, which will be the case if there is no RC number on the latest kernel version. So if you look next week, the kernel version will be 6.1. And that means the merge window is open, and you'll know the merge window is closed because you'll see 6.2 RC1 appear. The other kernel that sits into this space is Linux Next. So Linux Next is a merge of all those kernels, sorry, all the kernels that are being prepared by maintainers during this time. So during this time, we have private trees, we apply patches to them, And if we've registered them with Linux Next, then about a third of all, it's about 2/3 of all the patches that get applied to the Linux kernel have gone through Linux Next for additional testing. So it allows different maintainers to combine their code. It all gets merged together. It's a useful test target. So A allows testers to, so if I apply changes to my Next trees, then they land in Linux Next, and people who are testing Linux Next will be able to report problems with them to me. The other thing can happen as something like a SOC vendor. You can deliberately choose to test with Linux Next, so you can spot problems that affect your SOC before they land in mainline. And if you can get them fixed in Linux Next, they'll never become stable kernel regressions. Okay, so we're now going to move on from some of that kind of philosophy and approaches to kernel upstreaming to the actual tools and techniques that we promised you after the tips. So when we talk about these tools and techniques, the vast majority of what we're going to cover in the tools and techniques are optional. Nothing in this section is mandatory except for the comments I'm going to make about coding style. Maintainers don't care if you use special tools or not, or whether you're using the most productive mechanisms you can to interact with the mailing list. What they care about is that your patch meets the kernel standards. So I am personally very fond of tools. I like tools a lot. And I think they make me both more productive and more likely to meet the kernel standards because I am keeping an eye on my own mistakes. So I'm a big fan of using tools. So I'm going to introduce you to some of the tools that can be used to work in upstream. Not all of them I use, but I'm going to introduce you to a variety of tools. And to some extent, your job when you're listening to this section is try to figure out which tools are likely to suit you and how you work. So I'm going to introduce tools. You can choose whether you use them, which is not mandatory. But I believe that they can make you more productive. However, the first section is not mandatory. Sorry, it's not optional, it is mandatory because it's all about making sure you comply with the coding style rules. So many of the programmers working on the kernel are very strict about source style, and there are genuine cognitive reasons why that should be. Human brains work with complex pattern recognition, and I work on lots of different projects, so I flip between lots of different coding styles. But people who are full-time kernel developers have been looking in some cases at the same coding style for decades. And when you've been looking at that coding style for decades, your brain becomes able to optimize reading in that coding style because it can spot patterns. And when you are presented with code that does not conform to that pattern, all those unconscious mechanisms to help you read code quickly stop working. I've heard maintainers describe this as it hurts my eyes. And that's simply them having to bring in additional cognitive resources to study the code. That impedes review. If you impede their review for trivial reasons like coding style, they eventually get cross and give up doing the review. So it's not simply kind of pig-headedness. There are cognitive reasons why developers who work full-time on the kernel are going to be very, very assertive about making sure that the coding style is respected. The rough rules, in fact, I think the 80-ish has been expanded to 100 now. The basic rules are hard tabs. Hard tabs means you're using the tab character and it is rendered 8 characters wide. Don't think about using hard tabs and rendering them personally at 4 wide because it's more comfortable to you, because if you do that, you'll get some of the comment and other indentations wrong and it will look odd when it gets converted to 8 characters wide. The rules on the right margin are complicated. So 80-ish is still actually a kind of recommendation. but clarity is preferred over line breaks. So it is accepted that on modern widescreen, high definition terminals, such as I'm sitting in front of, 80 characters isn't, you can stretch the screen. So 80 was an odd limit. It was imposed by old terminals. It is still kind of recommended line break point, but people won't start, if you're keeping it clear, maybe 100-ish is allowed. I'm actually going to leave, this number is almost vague. Some of the tools are still configured for 80. The idea is that clarity is what really matters. So I've deliberately kind of shuffled that back and forth, because you will see lots of news articles saying it's changed, it hasn't changed, etc., etc. Break at, if you're going past 80, look for a line break, but find the break clean, or use tools to do this for you. It's a variant of the KNR style. I say variant because KNR isn't actually consistent with itself. There is one passage that doesn't form the same coding standards as the rest of the book. And these aren't random choices. I mean, particularly the 8-character wide thing makes control blocks very, very obvious, and it makes overly complicated functions very, very obvious. In other words, if your code collides into the right side of the screen, that doesn't mean the coding style is broken. It means you haven't composed your function, you haven't decomposed your work into smaller functions. So that's some of the basic rules of it. And it's critically important to match the style, because for all the reasons I've just been describing with these kernel maintainers, is almost all the comments you'll get if you don't conform to coding style is going to be about your bad style. It's not going to be about the substantive issues of your patches. And it basically means you've wasted a week, because you'll then have to wait, give some time for other reviewers anyway, and then fix your coding style. And then people will actually read the code. Before that point, they will only be commenting about your style. In the early days, I would strongly recommend you can use script checkpatch - strict, which will pull out not just coding style issues, but it will actually pick up common spelling errors, common typos, obsolete APIs. It will pick up all sorts of things. - strict means that it's bringing in warnings in particular that are imprecise and things like that. So whether you leave the - strict in place is a personal decision. Certainly while you're learning, there is going to be more you will learn from having - strict on, because you will learn more ideas than not. So absolutely early days, I would recommend having - strict. Whether you leave it on after you have used it to teach you about your own bad habits, that's up to you. You don't have to wait till you've written a patch to run checkpatch. You can use the -f argument. So if you've written a driver and you want to find out what's wrong with it before you check it in, or even if you want to check patch on save and get reports, things like that, you can set that up with -f. So if you receive errors from checkpatch, you should either fix the errors or send a bug report to the checkpatch authors. So if you get an error, that means that checkpatch is fairly certain you've done something wrong, or checkpatch itself is buggy. If you receive warnings, then think carefully about whether you know better or not. And adapt your Linux coding style for each problem. So try to get it right next time. So overall, don't assume nobody cares about white space. They do. Checkpatch will cover these things. There is a document called Coding Style, which is wise to read. Read Coding Style. Coding Style is a good document. It gets you started. You can pick up most of the bad habits by using checkpatch - script as well, if you really don't want to read the document, but I can't see a reason not to read it, to be honest. The other aspect is the opposite, however. Be very, very careful about fixing bad style that has sneaked past a maintainer. Coding style and recognition of coding style does improve with time. If you are just fixing this one broken line because it annoys you, is now a separate patch, because all that stuff we mentioned about splitting up patches is that you shouldn't fix the broken line in a different patch, because you're not supposed to make white space changes alongside anything else. So if you see things that are not right, If you can move past them without fixing them, it just uses less time. If the code is so poorly presented it's hard to read, you might consider sending a patch to improve the readability. That's quite rare anyway. So yeah, be careful about fixing any bad style. It means you cannot use automatic tools that reformat the whole file. If you have any automatic reformatters are really useful tools. We'll talk about one in a minute. But if it changes the whole file, it will not work for you, because it will constantly be making subtle changes to code that you don't want it to. Which brings us, in fact, to Clang format. Clang format is a white space formatting tool. It is designed to take syntactically correct code and automatically format it for you. It, in my view, makes a big difference to how much time you spend messing about with your editor. The best description, it was introduced at a C++ conference in this talk, Making C++ Easier, Faster and Safer by Chandler Carruth, who works from Google. And it comes down to mash a button and Clang format will reformat either what you've selected in the editor or the statement underneath the cursor. And it will not reformat anything else. So what makes Clang format special is not that it can format the code, although it is quite sophisticated at it. What makes Clang format better is that it doesn't touch other parts of the code base. So you can use it to format your own code as you write it without editing other previous states, which means it can be very aggressive. It means it can be very careful about alignments. You know, it's able to have extremely aggressive transformations because it knows it's not going to mess up any other part of the file. It has comprehensive editor integration. So I use it in Vim, but I'm told it's also available for many other editors. And it has very, very carefully crafted line break heuristics. Line breaking at 80 column or 100 column, wherever else, does require a great deal of care and multiple heuristics for how best to align, depending on the relative lengths of the function name, the argument list. I mean, it's not so bad in C. When you think about C++ with all the namespaces and the complicated types that you might have to put as the return value at the front. But even in C, when you have static inlines and a long function name, you can occupy a significant chunk of the screen and want to do different line break heuristics. There are ways that you can fix up. I'll put a patch written by an esteemed colleague. So if you've picked up a new driver from a colleague and its formatting is dubious, you can work through patches that they've given you and update them. You can absorb a patch and then figure out how to reformat the patch to make it better. That's not usually needed for stuff that's gone on the mailing list, but there are ways to cope with colleagues who aren't following the coding style very well. And Clang format has a control file in the Linux kernel since 4.17. I mean, if you're working on older kernel, A, bad luck, and B, you can backport that patch, which is why we've highlighted it. So let me show you what this actually means in practice. So I'm currently in top level of the kernel, and I've just got a couple of files that I could demonstrate simple use of Clang format. So in my case, Clang format is hooked up to my tab key. So this is mode editor, VI. You can ignore the comments in the red spots in the margin. That's because I haven't got a Clang format, Clang compile set in place at the moment. Here we go. Yeah. So here are some things that are arguably formatted slightly suboptimally. So this is indented 3 tabs, which is unusual. You'd either expect to be 2 tabs or aligned with the bracket. And I can simply go onto this line, I can press tab, and it has automatically made this change for me. So this is very, very simple. But the reason it matters is if I start with code that is well aligned like this, and I switch from copy kernel to, if I get rid of the no fault, which is a different method, I can just press tab to bring it back. That makes making small changes so comfortable and easy. That it allows you to think of these things. So it's a very small aspect at that point. But the key thing is it didn't change this line. This line is also badly aligned, but it's only changed the selection. If I wanted to change more, I'd have to go to the next line and tab, or I could perhaps select everything down to here and press tab and realign everything. What I think is interesting is you can see that difference in alignment here. So this one fits into 80 characters, so it stayed on one line. This one was broken differently. So those are very, very simple, nothing remarkable, but the key thing that's happening there is that we are only editing the lines that we're trying to fix, which makes the ability to keep pressing, to keep mashing that button, to just write the bit of code you care about, ignore indentation substantially, and just press tab to align things as best as we can afterwards, is a really, really valuable thing. And let's have a look at this as it relates to C macros. So, I mean, first off, I can reformat a macro to get a better, a more readable macro. So this is an example of the line break where it's trying to pull things back a little bit, because this isn't super easy to read. The KDB flags and the backslash, it recognizes that putting that all on one line, so I can use the brackets and all the shape recognition that I've got on C conditionals to see, oh, right, yeah, so that's doing a bitwise and this. It is easier to read in that thing. And it doesn't know exactly how I cognitively process, but it does know that pairing that bracket with that bracket on the same line tends to make code more readable. But if we want to see where it can really make a big difference, let's look at this next macro. The reason I've picked this macro is because it's unsafe. This has a very common error in C macros, which is that if it meets an else statement, it will do the wrong thing. So if you have nested ifs, you'll hit the dangling else problem with this macro, and it may bind incorrectly. So to fix it, you classically put a do at the front and a while 0 at the back. This is a classic C programming technique, so the if will still execute, but there is no possibility of a dangling else. And I can just press tab, and it has now taken that macro, created an attractive right margin. It's matched up the do and the while, it's matched up the if, it's moved all the indentation around. So with that one button, it's transformed a unreadable mess into a correctly formatted macro. And it can get even better. We can also maintain things further. So these text values are also unsafe, because if text were to contain a comma, we'd get some rather funky error reporting. So if we put these in brackets, we get what I call, it's a way to make the macro more hygienic, and it's now spoiled the right-hand margin, which is why a lot of developers don't maintain an elegant right margin. But I can mash the button and it moves everything up and aligns it. So that's giving you a sense of type and fix without damaging any other part of the document. So there's lots of other things that, it would prefer to format things like that differently, but it chooses not to. I mean, this is crazy formatting with this up out here. This is also very old code, I should add. The reason there are examples that I can find in here to show you is because this code is more than a decade old in a lot of places. So it doesn't make that change, because that change will be a pointless white space change, and all I wanted to do was make this macro safe. So it makes it quick and easy to use. Its recommendations are, in my experience, 95% of the time, I am happier to accept its recommendations than to hand format, because I would not have put the same level of effort into my hand formatting. So generally it gives a better outcome for less effort. And when I disagree with it, I can press tab, I can format it to improve clarity, and I know that it won't mess about with it in the future. So it's a really great tool. It's one I strongly recommend as a productivity booster. And if you want to see more, have a look at that talk. So that talk is quite long, but this link will jump you into the middle of it just when Chandler introduces Clang format. And he takes on a tour of some of the C++ features, enough to extract a round of applause from the audience. when he does the final demo with some rather complicated macros. And if you think about how hard it is to get an audience to applaud for what's effectively changing the white space in a document, that gives you a sense of the sort of capabilities that Clang format has. Okay, so we move away from Clang format, we move away from code formatting. So we now hit the optional sections, the productivity boosters. I kind of hope this is obvious, but to effectively participate and do upstreaming, it is important to know enough Git to do it effectively. You don't have to use Git to work with the kernel. In theory, you can work with patches and all sorts of things. But from a productivity point of view, other kinds of version control systems just are going to leave you working less efficiently than the other kernel developers. So you must be familiar with things like fetch and pull, add and commit. Those are kind of intrinsic to any work with Git. Rebase is perhaps the most important tool that you have to work with as a upstream developer. So I view developing upstream patches as effectively iteratively calling git rebase until your patch set is correctly split up, correctly behaving and everything else. And then every change I make from that point, so whenever I act to review feedback, what I'm probably doing is making the change requested, committing it, and then doing an interactive rebase to shift the change to the correct part of the patch stack. So interactive rebasing is just over and over again what you're actually doing to craft a patch set. It's what allows you to hone a patch set to make it as all those properties I described last week correctly split up and so on and so forth. Git rebase, run iteratively, is how you hone to get to that point. Obviously, Git format patch and Git send email are the best ways you have to get patches out of Git and into the mailing system. We discussed those last week. Cherry pick is worth knowing about for picking up various patches and backporting them and using them as a base to work from. Obviously, being able to work with branches is useful, and being able to use Git log effectively with searches and other such trickery so that you can mine the version history for information about particular files is also very, very valuable to have. You should know a little bit about merge conflicts and how to handle them, because it can help you avoid them for the maintainers, and the maintainers find merge conflicts annoying. But you don't have to be a high-level Git expert. You have to be able to use these commands competently. You don't have to be expert in its model and how to pick it up after you get corruption or anything else. But certainly rebase, I think, is that unusually advanced one. It's the one that tends not to exist in the GitHub common workflows. So it's quite common on GitHub to have a pull request with 10 different commits that have lots and lots of untidy history describing how you got there. The Linux kernel is not about how you got there. It's about making sure the patches that get applied pass code review. And the reason for that is that in GitHub, quite often they do a squashed commit. So all the commit messages disappear at the point you apply it and do the apply the pull request. In the Linux kernel, you're expected to tidy up that patch history yourself using Git rebase before you send the patches to the mailing list, because it's unreviewable. Reviewing 10 patches on top of each other, one after the other, bisectable, etc., it's just not reviewable. So yeah, the expectation is you've done lots of Git rebases to make your patch set as readable as possible. Okay, so the next skill that I think is very useful when you are working upstream is the capacity to exploit the mailing lists. And the only way, in my view, to exploit the mailing lists is to be able to filter them. It is essentially impossible to read everything that gets posted to the Linux kernel mailing list. There is just too much of it. But there's the corollary. If you don't read anything off the mailing lists, I told you at the beginning of today, kernel development happens on mailing lists. That's where it happens. If you don't read enough of the mailing lists, you are cutting yourself off from kernel culture. You're cutting yourself off from watching other people upstream and absorbing the lessons that they are able to teach you simply by watching their actions. So you must read parts of the mailing list to understand kernel culture properly. But you need to filter as aggressively as necessary to get the volume of email down to one that you are capable of handling. And that means either watching for things that interest you or for things that you're working on and everything else. So it's about filtering. So my suggestions on good habits for working with mailing lists. Particularly if you are working with the Linux kernel mailing list. I personally subscribe to the Linux kernel mailing list, admittedly through a special email account. And I delete almost everything I receive. I have an allow list approach to filtering it. So what that basically means is I have a couple of different filters that jump on backlight patches and anything involving debug, because I care enormously about both the kernel debugger because I maintain it and other debug technologies because I'm interested. So across the kernel, I tend to pounce on anything related to debug features. I have filters to pick those up, and I have filters to pick up backlight because I maintain it. And I maintain KGB as well. And I delete everything else. There is no value in you hoarding this huge volume of mailing list traffic, because quite frankly, the search engines and tools that we have in the available online are probably better able to search it. I mean, maybe if you're on a plane and it doesn't have satellite internet and you really need to know what's in a message, the probability of you doing that rather than watching the movie is quite low. Among those allow lists that you have, you can add a filter to keep an eye on code you've written. Diffs contain the names of the files. So if you have files you maintain or files that you have written and chosen not to be the maintainer of, you can still set up filters on the mailing list so that if somebody else tries to change that code, you can pick it up and send a reviewed by to help the maintainer. Similarly, if you've been assigned a new piece of work, you should go in and change your mailing list filters. You should arrange your filters so that now you can watch drivers in the subsystem you have asked to be contributing to, so that you can watch those drivers come past. You can see the maintainer interact with other developers. You can get a sense of how to effectively maintain within that subsystem. So one thing I think is important here is don't filter on whether something is being sent to or by a maintainer. I think that you want filters that are not specific to, not watching maintainers. You're wanting a subject, because the other contributors, the other reviewers around that space are also valuable to you to learn from. And they are also that policy that tends to exist in the Linux kernel, that if there is negative feedback, a maintainer will not apply a patch, means that you also have to make other people in and around the subsystem happy as well. So I don't like filters that are simply watching to and from maintainer, so you're only watching maintainer interaction. I prefer to search by subject, but your choice is your choices. What you will get back is still relatively high volume. If you're on a busy subsystem, when I looked at DRM drivers for a while, yeah, that's a busy subsystem. You get too much email. So my personal view is that it's not a good idea to set up a filter to pick up the mailing list traffic and put it in a spare email folder that you never read, for the simple reason that you never read it. I prefer to keep the patches part of my normal email flow and be aggressive with them. So first off, you can tag them so that they show in your mailer as different colors. So what that means basically is important mail from inside the company with you on 2 or you on CC ends one color. Stuff that you have not been sent is a different color, so that if you're doing quick scans or catching up between meetings, you don't read the mailing list traffic. The other trick is that you do need to make sure that only mailing list traffic is tagged. So if you're using colorization or other tricks, it is not whether something that is sent to the mailing list that defines the tag. It's something was sent to the mailing list and you are not in the 2 or CC. because if you're in the 2OCC, you didn't receive it from the mailing list, you received it directly, and you might want to treat it differently because it is explicitly addressed to you. And then the final thing is that once you've got those tags, once you can see that something is from the mailing list, you can be quite aggressive about deleting, because you know you're not in the 2CC. So literally, you know if it's tagged, it has come to you without anybody expecting something from you. Then if the subject line isn't interesting, you can press delete without reading it. You don't have to cover it. So that's my thoughts on filtering mailing lists. There are lots of different kind of personal productivity habits related to handling email effectively. So my prejudices may not match yours, but I think they are food for thought, particularly that idea that you can filter aggressively, and if the volume's too high, you can be busy with the delete button if you've provided yourself some additional filters to allow you to be aggressive with that delete button. So another technique, this is orthogonal to the previous, you can implement it however you like, but one technique that is quite popular to some extent is to create a throwaway cloud email account, whether it's Gmail or otherwise, to create a throwaway cloud email account, subscribe to LKML from that account, and set up forwarding filters so that if the filter is matched, it can be forwarded to your work email perhaps. And if the email is not matched, delete it. Right, so if the email is not of interest to you, just cause it to be deleted straight away. There's a couple of advantages to this. One is it makes the colorization filters super easy to write. So the colorization filters I mentioned before is super easy to write because you will end up with an X forwarded for header, which you can specifically match and see if it came from your special account. And if you forwarded from your special account, you can get the colorization, no problem. This means there's absolutely no risk whatsoever of accidentally colorizing mails which were copied to the mail list, but where you're in the 2OCC. It's more complex to set up. So there are disadvantages as well. The reason that kind of works really well, particularly if you are using multi-client email. So at Lenaro, I have a work Gmail account, which I can scan from my phone, and I can scan from other places, and I can set up filters using the Gmail rules. But quite often advanced filtering, like the colorization, happens in a mail client, not in a not at reception. So if that's happening, you tend to find this special email account is a better way to manage the volume for you. That one's very, very optional. That suits some people, other people hate the concept. So that's just shared because it's an interesting idea. Big one, there we go. Okay, so the other way we can get benefit from mailing lists. So everything I've said about subscribing to keep track of things, I find quite useful. But there are other ways we can take advantage of mailing lists. So one of these is called public inbox. So public inbox is, how can I put it? It's a mailing list archive. It's a way to take mailing lists and archive them in, I think, Git format. The key thing is there is a public inbox instance called law.kernel.org, and it allows us to gain access to history of things. So it's trivial, for example, to hand draw some basic automation. So here we have a link to law.kernel/all, and then this text here before the /raw is a message ID. It's a message ID for an email that I sent. And if we visit it, it is the raw contents of the email. I can't remember what this was. Oh yeah, it was aligning KDB to the scheduler. So this was a patch that was sent out, and that gives me a raw copy. And it allows trivial automation like grabbing it and fetching it with curl and piping it to get AM. Or if you want to reply to a message, if you've not received a message for your inbox, so you've seen it in a public mail list archive or somebody's pointed out to you and you want to reply to it, the first thing you're going to have to do is to get a copy of that email into a mail client somehow so that you can send a reply. And you don't have to subscribe or find it or ignore it. That means you can just grab it into an unsubscribed message. It's in mailbox format, and you could point your mailer at it. So that's the syntax for sending it into MUT. But if your mailer handles mbox style of mail archives, then you can just open it in your mailer and send a reply. So it can be very effective ways to reply to emails you've become aware of without having to have them land in your own email. Oops. So I feel like I've missed a step here, but I haven't, have I? Yeah, okay, yeah, that's what's going on. I remember. Yeah, beg your pardon. Right, okay, so these tools align together. So we have that law.kernel.org, which is that public mailbox instance where we can grab patches. It's a canonical instance that should archive almost all of the kernel mailing lists. It provides a law.kernel.org is not built around being attractive, it is built around being functional. And the web interface is built around various use cases you might have, following threads, raw mailbox download, etc., etc. And if you're an infrequent contributor, then simply the web interface followed by raw mailbox download may be sufficient for you. So if I pull up law.kernel.org and let's search for backlights is the first image. And I might be interested in this particular patch, which is to adopt the use of sysfs emit. So this is a small cleanup that makes some of the sysfs integration a little bit more elegant in one of the backlight drivers, or three of the backlight drivers. And it may be that that web search and this raw link, which allows me to save as and download my mailbox, that might be all I ever need. I might not need to use any more advanced tools. That already allows me to grab mails, reply to them, all in the web interface. But there are these additional higher value tools that can sit over the top. So Lei is a tool, L-E-I, is a tool to synchronize part of a public mailbox, a public inbox with a local email folder. And it can synchronize either to, strangely given the obsession with mailbox everywhere else, it can sync to either Maildir or an IMAP server. And that's an alternative to subscribing to a mailing list. You can subscribe, synchronize, to a search of a public inbox. It's an excellent alternative to the Gmail filter, because this allows you to set up on your workstation a search string that searches a mailing list and synchronizes to a local email folder, and you can then arrange perhaps for it, if you're synchronizing to your IMAP thing, you can then arrange only to look at it at a particular point in your working day, so that you can arrange to have not read mailing list email in the early part of the day when perhaps you're most productive, and you save your time processing email to a little bit later, things like that. So it's a different way to subscribe to mailing lists. Effectively means you don't have to subscribe to the mailing list, you actually synchronize with them retrospectively. It's not a technique that I use, but it's a technique that's available. And the other one, is called B4. Sorry, I was one full screen there. B4 is best thought of as an advanced and feature-rich alternative to grabbing the URL and GitAM. And again, it's built around message ID, and it has two features that differentiate it from just a raw curl. One is it will follow patch series for you. It will even provide mechanisms to automatically discover patch series updates. So if you try to fetch version 4, I think it's able to try and help you identify whether version 5 exists or not. The other thing it does is it collects tags for you. So if tags have been posted to the mailing list, it allows you to collect tags. So B4 is part of my work. So when I grab a patch and ask Git to apply it for me off a mailer, before it applies it, it will use B4 to get a new version of it with tags applied. So that's how I, as a maintainer, can maintain my my patches, my maintain tags when I apply things to the kernel. And if anybody is wondering, both Law and B4 and Vigor, which is the name of the mailing list server, are all Star Trek references. I think there are various forms of Android in the Star Trek universe. That's why they are quite varied and don't make sense if you're not a Star Trek fan. Also, B4 is actually really hard to search for. B4 is not a very unique string. So there is a link to B4 explicitly here. I beg your pardon, that's B4 telling you how B4, the Star Trek thing works. So finding B4 you can do. I mean, if you go into the, excuse me, if you go into the general search and look for B4 patch mail, you'll tend to end up in these types of articles about how to use B4 effectively. And eventually you do find the appropriate GitHub link. But just searching for B4, you don't really have a chance of finding the tool. And just to give you a sense of what you can do with B4, so this was the patch I showed you before. Going to grab the message ID, and I can go to B4. And the various options I have, I've got things like mailbox, apply mailbox. I'm just going to show you the mailbox approach here. But it does all sit together. That's annoying. Let me try that again. Okay, I might have to type it. So I can't copy and paste between my browser for some reason. I'm not quite sure why that is. That's gonna be fun. So B4 mbox, this is gonna be quite a challenge. Hopefully I'll spell that correctly. Nope. Okay, let me double check. In fact, I'm going to skip that demo and do the more complicated one. I was going to do two demos. I was going to do this demo, which is a single patch, and I was going to do a threaded demo. I think the threaded demo is going to be more important. So let me find this one. So this was a long-running patch. It's also easier to type, thankfully. This was a long-running patch. You can see it's in version 10. It's gone through several versions. And I'm going to grab by message ID again. So cover.667877096. So this would be a lot more professional looking if I had got the copy and paste working. That's better. Okay. So that's managed to grab not just the covering letter. So this is the message ID for the covering letter, but it's actually going into the thread overview and grabbing all the patches from the thread overview. And I can have a look at it as a mailbox. I could go in and I could reply to, I'm not actually going to go and actually start proposing the reply because my muscle memory might kick in and I'd send Peter a message by mistake. So I can go in, I can look at the messages, I can review them, I can send messages to people as I need. I could also then git am the mailbox and the two patches would be applied to my kernel. We might find they're already applied actually. No, it can apply to kernel, it can spot a few small differences, things like that. I can combine them together into one trick. So this is the one that's Pat's mailbox can be useful if you want to reply. AM can also be useful if you want to test patches. So if somebody sent changes to your driver and your ambition is to check they work and send a tested by, you can create a branch, you can git AM. It will attempt to apply the things. Here it's suggesting what I need to do it. And that's the sort of thing you can do with B4 just to be more efficient working with a mailing list, particularly if you want to test other people's patches. So B4 is very powerful. Oh, there's one more thing I was going to show you, which is B4. Man B4? Yeah. Man B4 is just showing you the kind of things you can do. So we've got apply patch series to multiple repositories. We can work with pull requests. So if you want to test somebody's pull request, which is going to be rarer, but some people making very large changes will send pull requests to maintainers between themselves. You can grab at that point. Diffs and a couple of other things you can look at. And there are also now, and these are sufficiently new, I haven't looked at them yet, mechanisms and tricks to help you prepare for submitting changes by patch. So I haven't looked at these, but it is interesting that these ones have been around a long time. They were designed to help maintainers and to help testers. So although it's called maintainer oriented, B4AM is still very useful if you want to test patches off the mailing lists. But yes, to see contributor oriented concepts being thought of is very new. I will definitely have to look at these in the future to work out if we need to talk about them, but for now they're just something that you could look at if you would like to. Final thought for you is that normally you are recommended to use git send email to share patches. And you are also, as I've spoken earlier, required to have a mail user agent that is configurable for plain text emailing. You can configure your primary emailer to make it possible to send plain text emails from your primary emailer. I've worked that way for some years, back when I was using Thunderbird. There is an alternative though. You could have a kernel contributing mailer and a regular mailer. And if you're doing that, you could use things like lay to create you a secondary mailbox. So here I am grabbing everything that was sent to any Linux mailing list where Daniel Thompson at Lenara.org was in the 2NCC and it was less than a month ago. And I can sync and I can keep resyncing. And I could then read my mail, kernel related email in that sense. I could reply to it in MUT, which is of course text by default. And I could handle that completely different to my professional email. It's not necessarily the best way to work, but particularly if you find it very, very hard to build text-based email into your regular corporate email flow, you could look at trying to figure out how to set up a second emailer. Okay, the final thing about talking is mentioning socializing on IRC. The problem with IRC is that it's not mentioned in maintainers. So it can be slightly difficult to find the IRC channels you want to work with. So the best we can offer, if you go onto things like, what's it called? libera.chat, which is one of the preeminent ones, or OCFC. The two mailing lists, two IRC servers I put in slides last week. Then you can use an internal message to the what's called Alice, the Advanced List Service, to help you discover. Basically, this is how you work in IRC to discover lists that you do not already know about. In this case, we're looking for lists that start with Linux -M. And then wildcard, or you can just get rid of the M and search. So that's how you can discover rooms that may be of interest to you, particularly things prefixed Linux are most helpful. So being able to list, you know, if you were looking up, I'm not sure what subsystems begin with M right now off the top of my head because mouse is input system. But yes, if you're looking for particular subsystems, Linux minus first layer of subsystem, you might well find that's where the channel is. If you are working on IRC, it is perfectly acceptable to sit and watch until you feel confident with how it works to contribute. And the key insight about IRC is it is generally not wise to ask permission to ask a question. So hello, can I ask a question? Tends to not get that much notice. IRC is instant messaging. but not with quite the same expectation of reply as if you sent a personal WhatsApp to somebody. So if you have a question, just fire it out. A lot of people will be at lunch and so on and so forth, or asleep, and we'll see the question when they get back and see if they're interested in answering. But yeah, if you do want to contribute, generally look at how other people interact, but if you have a question, just ask is generally the best way forward. It can be a place to follow up on code reviews, but not to ask for code, sorry, to follow up on code. So somebody gives you a code review and you've had a couple of back and forths and you don't understand each other, it can be a good idea to pop up an IRC, see if you can find a variant of the maintainer's name in the chat and see if you can make contact with an IRC to say you don't understand what's been going back and forth in the code review. It's not a place to solicit a code review unless you really know the maintainer very well. But it is a place where you could follow up on a code review if you didn't quite understand what's going on. Or, as the example shows there, that you want to try, they've made a recommendation and you want to finesse the recommendation and have a quick discussion about whether that approach is better. Okay, so we'll move on to the last few bits of tools. The other tool that I think is critically important for upstream kernel development is a really effective source code navigator. Now, obviously, some editors have source code navigation built in, and you'll wonder what I'm talking about. But ultimately, the capacity to move around the kernel symbolically, finding where a symbol is implemented, where a symbol is consumed, what the definition of a symbol is, and so on, can make you very much more productive as a kernel developer. And this applies equally to upstreams, because a maintainer will sometimes ask you something like, are you sure this is safe when such and such a thing happens? Question mark. That means they suspect your code might be faulty, but they're not quite sure. Asking it as a question makes it your job to find out. And I don't know is not going to be an acceptable answer because you are proposing the change. It's your responsibility to know how it works. So that's when source navigation comes particularly into focus for upstreaming, is that if you're asked, are you sure this is safe when, you're going to have to use source navigation to prove to your satisfaction that it is or isn't safe. And source navigation is a big contributor to that. I mean, it's also more effective at making you a kernel developer by introducing into APIs and allowing you to follow up on points of interest. But specific to upstreaming, there are questions that will require you to do quite a lot of extensive source navigation. So you need to have one or more indexing tools integrated into your workflow. So there's a couple of things built into the kernel. So there are 3 source code navigators that the kernel knows about intrinsically: CTAG, CScope, and a thing called GNU Global. And these are built into the make system. You can literally say make CScope, make CStack, make tags, or make GTags. And these will run the indexer over all the drivers and your current architecture. There are pros and cons to indexing all the architectures. So the main con, if you index all the architectures, is if you follow something like Spinlock or inter-architecture code, you get 16 implementations, which can make parsing easier. Studying all the code is really great for portability problems. If you want to know that you'll be sure that you're using Spinlock and other architecture-specific tools portably, then having a look at multiple implementations can be useful. But that's quite rare because mostly the portability requirements are listed in the documentation, and the rest of the time having all the implementations from all the architectures just slows you down and makes you have to work cognitively harder. So I quite like the fact that it restricts you to only your current architecture, and that gives you the tags that you need. So obviously CTags is big in the Emacs world, I believe, and so on and so forth. You can use more than one indexer. If you find that one is really good for one set of tools and one is really good for another set of searches, you can use more than one. I don't. If you want a sane default and you don't have an editor to which these things are intrinsically built, one possible sane default is make CScope, which will generate an index, and to run CBrowser, which is a very simple TK program that allows you to separate code navigation from editing. And then when you want to edit it, there's a little editor menu you can pull down. It's not necessarily a recommendation. This is a sane default if you have no idea what I'm talking about and want to sort of just type a few characters and get a demo. So that's a thing, but ultimately source navigation is critically important to your effectiveness as a kernel programmer. There is one subtlety in some of the source navigators, and that is based on finding structure definitions. So there's a difference between structured definitions and structured declarations, and some source navigators look for structured declarations, and the problem with that is because of type defs. So the coding style for Linux kernel says it is a mistake to use type def for structures to pointers, and generally it is. It's far clearer to say struct virtual container star p than virtual container underscore t star whatever it is. The problem is that wherever this appears in your function header, that technically, the reason this is considered better is that because this is opaque through the pointer, the kernel doesn't actually need to know what virtual container is to figure out the size of p, because p is pointer sized. And it doesn't need, you need a type def to parse. So you have to have previously seen the type def in order to parse, but you don't, because we've got the struct thing here, this will parse whether or not we've already defined virtual container. So it makes headers more portable and adaptable. The problem is because it's a definition, it gets picked up by the source nav. So if when you search for a struct, you get 400 hits, most of which are function prototypes, you could just fall back to this git grep, which relies on the coding style to find the one place where it's defined in the kernel. So if basically you get too many hits when you search for virtual container, you can fall back to git grep. There are also web tools that can help with source nav. These are really great for looking at big picture because they generally have indexes of multiple versions, so you can step forward and backwards in time. Links are durable, so you can share them with people. So you can say, this version here has this problem, and you can link to it. It's particularly good if you are traveling with a Chromebook and you haven't got the kernel sources on your thing and you want to answer something. So source navigating on the web, it has many advantages. Elixir is one of the commonly run ones. So you can self-host your own Elixirs if you want to run in-house tools to track your vendor kernels. But you can also go to things like elixir.bootlin.com, which is a popular and well-maintained Elixir instance. And it just allows you to see spelling this right. It allows you to search for the debug state macro we were playing with earlier. Brings it up, shows you the line number. I can then jump around through the various print state functions, find out what that was, and so on and so forth. It isn't as effective as well-integrated local tools, particularly because every time you click on a symbol, it's stateless, and you end up stepping through this web thing to move to the next place, which can get a bit overwhelming for certain of these functions. But it's still a very effective way to learn more about the kernel using the web tools. So after that, that's source nav. Like I say, some editors have got that built in anyway, particularly if you've bought in the appropriate plugins to index the sources for you. But where you haven't, that's a very effective tool for making yourself able to see further. So next tools are the static checkers. Static checkers are almost all about finding issues earlier than you might otherwise. So fewer issues that come from code review allow you to deliver code upstream more quickly. So if you run relatively heavy static checking, you're less likely to have bugs in certain parts of your code, and there'll be less for maintainers to be distracted by while they're looking at your patch. The other time you'll have to use it is some maintainers will simply say, your patch introduces a sparse warning, fix it. They won't necessarily tell you how to run sparse because they believe you should already know. So yeah, static checkers you might also be running because somebody's told you you need to, and you need to know how to run those static checkers. So we can look at different ways you can integrate static checkers into your workflow. how you like to integrate static checking is a very personal decision. You know, you can use git commit hooks, you can run them pre-test, you can wrap them up in wrapper tools that allow you to operate them en masse and run a whole bunch of static checks at once. You can push it to a Git server and get a CI tool to run the checks for you, so that your process, you know, your company process becomes pushed to Git server, static check happens magically, you get an email telling you whether or not to send the patch out. The different ways you can integrate static checkers vary both on your wishes and your company capabilities. So at the moment, we're just going to tell you what the tools are, and you can try and think about how to integrate them. So the general way in which static checkers are built into the kernel build system is using this check mechanism. So check is basically a pre-compilation that happens. It runs before the compiler. It preserves the C flags that you would be handing to the compiler and runs it on a source file. And by default, check equals sparse. And you have two options then, C equals 1, which will call check before every file is compiled, and C equals 2, which will call check for all files, whether you are compiling them or not. So C1 is a kind of check as we go. C2 is a check the whole source tree every time. And ultimately, C flags will contain lots and lots of GCC specific arguments. So sparse will then be called with all the huge number of arguments that the C compiler has. And sparse knows which one it cares about. Obviously, it cares about things like -i, so it can simply process correctly. And it knows which ones it doesn't care about, like warning you about bitwise. And it doesn't need to care because the compiler's doing that for you. So the checkers that you can plug in, you have sparse, which is the default, stands for semantic parser. And basically, it generates a parse tree from the C code and then runs checkers over the results. And it's got a variety of different checkers. Its primary checking feature is built around an enriched type system that the kernel has. So the kernel just does not just have pointers as C does. The kernel has pointers that are tagged for particular properties. So in particular, it uses this enriched type system to track the difference between pointers to user memory, pointers to memory mapped IO devices, and pointers to kernel memory. And it allows to use that enriched type information so that if you were to dereference a user pointer without using an appropriate accessor, you can get an error because you're not allowed to dereference user pointers from the kernel. Similarly for MMIO, if you access MMIO without using an appropriate accessor, that enriched type system allows you to say, that's an error, you didn't use readle, which is necessary on some architectures and not others. It can also look for things like per CPU pointers, which again use the enriched type system to say you're not allowed to dereference this without an accessor. You can look for a couple of different types of bitwise mistakes and lock holes. And there's some examples of the warnings you can get back off it in this example here. So incorrect type for argument is a different address space. That is an example of what happens when you read a user pointer directly. Cast removes the address space. So here we've got a cast that takes a user pointer and casts it to a different, or an MMIO pointer, and casts it to a different address type. We've got a cast, an implicit cast in this case, for a type that we've marked as being not allowed to be implicitly casted. So it's all sort of things that can keep an eye on you based in particular on that enriched type system, which is what sort of sparse's secret sauce is. There are other more generic checkers that look for common bugs, but sparse's kind of special feature is that enriched type system. Smatch is another tool. It's based on the sparse code and it's able to look for other types of problems. It is taking a different position to sparse in the sense that it's prepared to use heuristics and can have a relatively high false positive rate. But in exchange for that, it gives you more things to think about. Again, you can run it simply by dropping check in and replacing it with smatch -p kernel, which puts it in kernel mode. And it can give you things like, it looks like this static link buffer's been overflowed. We've called this with bad flags. These are a number of examples we've kind of pulled out that come out when you run it. Unbalanced use of bottom half disables. So this is quite an interesting tool. Like I said, the relatively high false positive rate does make it awkward. But if you're working with a driver that you're developing at the time, then these kind of things are useful. If you have make C=1 turned on, and you're looking at the errors that get reported on your own driver, and just your own driver, it gives you things to think about, although you may never get the warning countdown to 0. Coccinelle is quite a peculiar thing in many ways. So if you've come across Coccinelle, it's usually described as a program matching and transform engine for semantic patches. And what that means is, let's go by example. So this one at the bottom is picking up a common typo. It's not really a mistake, it's a typo. So you're basically looking to see if something is not null and one of the fields is not null. And if you do that with an and, it will short circuit and not do what it looks like. It will just say, oh, it's not E, so E is non-null, therefore I don't have to evaluate this one in the first place. In actual fact, it will also null fault if it goes the wrong way. So it's a typo. It should be using the or conditional. There's no way that code could ever be correct the other way around. Like I say, this is a null pointer access or a no op. So yeah, it's definitely wrong. So we can recognize it. We can say if there's an expression and an identifier on a field, if the code matches this, then replace it with that. That's what the semantic patch is. And so regardless of what the expression E is, this could be a complicated bracketed expression, regardless of what the expression E is, this will match and fix that bug pervasively across the source base. However, it has multiple modes of operations, one of which is simply to find and report bugs. So it can be set up in a mode where it will use this information to find the bug related to the incorrect use of or and, but just give it as a static checker. So ultimately, the library of there's a library of semantic patches in the kernel to pick up on common errors, and this is a way you can run it. There are other things you can look at in this space. So there are static checkers and other things you can work with. So CVP check is just something I'm not going to talk about here, but you can work further. There's been lots of, in fact, remind myself where W1 sits these days. So what has happened recently is W error has been added to compile check builds in the kernel. So warnings are becoming more and more averse to warnings in the default settings, but you can also use things like W=1 to increase the level of warning, or even up to very high levels if you like the false positives. There are reasons that some of these warnings are disabled. Because the false positive rate is considered high. The problem with false positive is that high is a relative term. As a developer, you can tolerate high levels of false positives on the code you're writing because you can remember which ones don't apply to you and just keep writing. Once that code gets committed, 10 false positives in each file becomes completely unmanageable. So, like I say, tools with high false positive rates are still worth working on your desk. They're just not worth using in CI systems. And there are other static checkers you can look at, check stack, namespace check, and there are even ways to start integrating some of the Clang and GCC static analyzer tools, which don't integrate using check. They're basically enrichments to the compiler. So make help is always an interesting place to look. You can see some of the stacks, some of the checks and static capabilities that it has to help you find bugs automatically. Finally, there are tools that can bring it together. III is getting quite old now, and it is essentially unmaintained. It's basically a library of shell scripts that can build the kernel. It can apply lots of static checkers, warnings, sparse, CVP check, Coccinelle, and SMatch, and generate your report. The really nice thing about III is it runs and gets the report before you make the change and after you make the change. And it only tells you about the new warnings, which again is a really good way to cope with false positives. You can turn on you can turn on checkers with significant false positives, W=1 and smatch, and all the existing warnings in the kernel will be disregarded, and your report will only tell you about the ones that are as a result of your changes. So this is a way you can wrap things up. Like I say, III is quite old. I am not currently aware of anything newer, although I think the case is that as we've moved towards CI systems, you would tend to hope that you have a CI system that can run these kind of things for you and give you a warning report. So this is how you can run it on your desk if you want to. And the reason I think this tool is being left behind is that CI is starting to replace it. Final thing on tools and techniques is regressions and bisectability. So ultimately, this is about automating things. If you automate everything, then when you find a regression, you can find out how it was introduced. What we mean here is maintainers are doing their best to make sure every commit is compilable, and they mostly succeed. That makes it possible to do a binary search through the history, looking for when a regression was introduced. And we have a tool called git bisect, which can run the test for us automatically. What I mean by always automate everything is you should be in a position to have a shell script to hand to git bisect. So you can do git bisect by hand. You can say git bisect start, you can run some manual tests and then say git bisect good, git bisect bad until you get to the result. The problem with that is that humans are tremendously error prone. And if at the end of 2 hours of tedious bisecting, it tells you that it is given it an inconsistent result, you have no way of knowing if you gave it an incorrect good or bad at some point in history, or whether the test you're running is unreliable. So by automating, you are able to remove the human error. So that requires you to run a shell script, write a shell script that can compile the kernel and run a test. And that running a test means you can return value to say the kernel compiled and the test passed, return the value to say the kernel compiled and the test failed, and a special value to say the kernel will not compile, please provide me a nearby kernel instead. Now, even if it looks difficult on your platform because you can't automatically deploy from your workstation to the target, reboot it and have it do work, it's still worth attempting to write such a script because, as I said, manual bisection is hard. Beg your pardon, let's see where I'm going on this. Yeah. Because manual bisect is hard. The advice I would offer is that if there is a manual step that you have to perform, you can direct the computer to instruct you to perform it. So in other words, it can do the compile for you. It can then ring the bell a couple of times on the terminal and print you an instruction saying, please poke the test board and press return. And then it will take over. Now you've put the test board into a provisioning state. It will then do the provision, connect to the target, run the test, wait for the next cycle. That manual step has two great purposes. One is that you can ignore the system the rest of the time. So you're simply being directed to do something mechanical and press return, something mechanical and press return. And it means you can go and do something else. Your brain can go off and learn Rust or do something much more productive than sit on the keyboard constantly compiling and running, manually running tests. More than that, you'll also have a good confidence at the end of that process that the result is correct. So if it is unstable, it's because your test is bad, not because you made an error while you were bisecting. One thing to mention about III is that bisectability testing is among its skill set. So you can say, I would like you to test every patch in the series. Again, good CI systems would also be doing this for you. So if you have in-house CI, these things can be relevant, but that's how you can do that on your desk if you would like to. So on that kind of aside about automate everything, it's your platform. In the early days, particularly for a SOC vendor, nobody is going to be more motivated than you to keep that platform running in a healthy manner. Setting up automatic testing of basic kernel build and boot can be very, very valuable. Now, I can't go into details of how to set up comprehensive CI or to build your boards for optimized for CI environments so the resets are effective and everything else. You know, there are public kernel labs, there's Jenkins, Lava, kernel CI, other contributors in the space. But it is definitely worth considering if you're starting to upstream a platform, asking your manager what automatic testing is there to help you, if there isn't any, is a worthwhile challenge to give to your manager, to offer the developers a way to automatically run tests for what they're building. And particularly once kernel goes upstream, you can then run Linux Next through automated testing if you have that capability. That then gives you early warnings that don't require developers to keep doing work. Rough sort of summary of good automation is it must be accessible, meaning that when something fails, it must be fairly easy for developers to reproduce the failure either on their desks or by poking the CI system with different kernels to explore. It needs to be scriptable in the sense you need to be able to hook it up to something like git bisect to find problems. So if we have a test that fails and we can isolate it so that you can send a command to boot the board, run a kernel and so on, it's important to be able to supply the kernel in a scriptable manner so that you can attach a git bisect to it at the other end. And it has to be understandable. You know, the test reports must be rich enough to allow you to get a sense of triage without getting developers to have to reproduce it. Like I say, it's a very deep subject that I can't go into in great detail here, except to say that there are a number of excuses that come up when you say you should automate stuff. Well, somebody should have given us a board farm. It's far too much work. We need special equipment, and CI isn't really my thing. Ultimately, computers are really good at accurately repeating stuff, and humans aren't. So wherever you can find things you can personally automate, whether that is the automation you use to send and check patches with checkpatch or anything else, finding automation in these upstream workflows does boost productivity. It's a tool and a technique that should and could work for most people. And that counts for personal as well. So this is even further, so I really do consider automating things. You know, personal automation can help you follow what you've read in documentation. I have some scripts that I use. I don't usually share them in training because they're personal. They are adapted to the way my knowledge base works, as in I have I keep a knowledge base in my editor that reminds me how to do things. Parts of it are semi-automatic and allow me to do some of the Git flows. Now that's a very personal thing to how I manage my own engineering logbook effectively. So it's not that I think that you should replicate my scripts, you should replicate those concepts. Many parts of submitting patches can be partly or fully automatic. You know, I don't use git send email. I use a wrapper shell script that does a couple of the value add things that I need before I send the email. So whatever you're doing, build testing, runtime testing, patches, sharing things like that, you should always be asking that, can I automate this flow? But, you know, people call the email workflows a bit clunky. And that's probably because they haven't automated the bits they're finding clunky. One trick I do use quite a lot is I have a shell script called git release, which is a wrapper around git format patch, which automatically looks up the to and cc addresses from a control file, and it gathers the text from the covering letter from a template file and applies it to the cover letter template. So in other words, when I type git release, it's gone to look up in a knowledge base all the information you need to complete the release without having to do any hand editing of any of the .patch files. So then I can read the patch files and send them version 2. It really pays off when you do version 2 because I can simply update the changelog in my template text file for the cover letter, run git release, and it grabs all these components. And the funny git hooks, again, are areas to avoid mistakes. You can set up checkpatch.perl so it runs on every commit. Although I would advise you to allow an environment variable to bypass it so that you commit work in progress patches when you need to. Okay, so I'm going to do what you can do when you're ignored at a fairly gentle pace, and I'm going to go very fast through the mailbox upstreaming story because we're running short of time and I want to get the balance right. So what to do if you're ignored is probably the most important question that will come up during upstreaming. And the first thing you should be doing is not looking outside at the world, look at what you've done. Make sure that you have done everything you can to make the code flow as best as you're able. So there's a checklist I would put up here. So is the patch set easy to absorb? Have you made it as easy to review as possible? Is it clearly described? Does it give some hints on how it's tested? Is the changelog good? If you have made the patch set difficult to absorb, the maintainer may not really be ignoring you. They've just put it in a bucket of low priority stuff that is time consuming to review. They simply haven't got to it yet. The other big thing you might have got wrong is to put incorrect people on 2 and CC. Some maintainers prioritize stuff where they appear in the 2 because that's when somebody has requested an action from them. So make sure, have a look at maintainers, make sure that 2 and CC should be highlighting the patch to the right people that you need. Check the mailing list, look for other people contributing. Is review normally going to take a long time? In which case you might just have to feedback to your manager that this is normal. Or is other code review taking place? Has your patch been picked out and not sent to the mailing list? Go and check it in the archives. Make sure it didn't get picked out by an anti-spam action somewhere in the root. 4 is actually a restatement of 1 in some sense. If it's a large patch set, can you split it up better? Can you make it easier to review? Finally, consider when the merge window is. So if you've posted it at maybe RC7, RC8, when the maintainer was busy doing some testing, and then during the merge window, maybe they're ignoring you for those 3 weeks because of the timing. And the final thing is if you're at the point of resending or sending version 2s and 3s, did you collect all reviewed bys and act by tags? Because it's not just that you're responsible for adding it and you'll annoy people if you don't. It's also the sign that other people care about your patches enough to review them, and that adds weight with the maintainer. So you're simply missing a trick if you don't collect those patches. It's in your interests as well. So simple things you can do. The resend. This is the recommended approach in almost all cases. If it's gone maybe 2 weeks, those 2 weeks are not the merge window. And so there's a possibility your patch has been genuine overlook or mistakenly archived or deleted. You could just send it as a resend and then send the same patch again, perhaps collect tags if necessary. That's the kind of general recommended approach. A technique called the gentle ping, where you just reply to your own email with the word gentle ping in it, is starting to become increasingly common. Maintainer reactions to it vary considerably. Most don't mind, but some have definite preferences for resends. And you can perhaps look at the mailing list archives to see what's happened. Here's an example of a gentle ping. Gentle ping on this patch series. It's been 3 weeks now without any reply. Please take note and follow the kernel release cycle. So in this case, Lee is pointing somebody at the kernel release cycle. Said the patches were sent at RC7, so it's quite late, which is why they took no review, and that they probably shouldn't expect any patch review to happen until RC1 now. And then a second observation, there's no such thing as a gentle ping. If you think the patch has been dropped, send a resend. The reason for this, incidentally, is that if the gentle ping is arriving when the patches have actually been mislaid, a resend puts them back in your mailbox so the maintainer can process them. A gentle ping, if it has been mislaid, which is the assertion you're making with a gentle ping, means that the mail isn't in somebody's mailbox and they'll have to go and use something like before to find it, which is fine, but it's just annoying given that Git send email is semi-automatic. It shouldn't hurt you to send out the resend as a courtesy to some extent. The final thing before we go into what to do with maintainers and what to do if you're genuinely being ignored. So you've gone through your checklist and you can't see that you've done anything wrong. Maintainers are not all the same. I've talked about maintainers collectively throughout this course because I have no choice. There is commonality in the patterns and behaviors of maintainers, but they're not all the same. They will have subtly different likes and dislikes. And it can help to know the working practices of the maintainers you are actually working with. So look at those mailing lists, find the details, learn about the maintainer you're working with, and that you are working with them in a manner that other people have found effective in the past. And when your goal is to get attention from maintainers, firstly, maintainers only pass. Secondly, your schedule has no meaning. So both those facts remain true when your goal is to get attention from maintainers. We've talked about motivations, we've talked about lots of things. Trying to poke a maintainer into action has to be done with care, because you're essentially saying they've been ignoring you. So be sure that you're not being impatient. Go through that checklist, check if your communication can be improved. Look for reasons for them to be busy. There is the merge window. There might also be comments on the mailing list saying, I'm not doing something this cycle, or we're not looking at it at the moment. Have a look. It's also a very, very good time to stop and think and ask advice from people you trust, whether that's a manager, an experienced colleague, somebody using a mentoring. You could contact LDTS and ask us to take a look at the patch, support@lenara.org. You could ask us to take a look at the patch and see if we can see anything that you could do better. But ultimately, finding someone you trust to find advice, it's a good point before you start poking maintainers for advice. As we mentioned multiple times, I think now, 2NCC does matter. Getting it right does matter. It does make sure. So be aware that that will happen. Maintainers are often overworked. So what that means in particular is critical messages should always be in the first paragraph of emails that you send. The patch description matters. The cover letter matters. Why is this patch series important? That first paragraph. It's quite common for people to put lots of effort into making the code perfect and put in substandard descriptions that don't make the patch look important. Make sure that you're describing what it does as early as you can in your mail. And patch bombs are probably the biggest thing reviewers will be inclined to ignore. So patch bombs, that means very, very unnecessarily large, where you've got 30 patches that don't need to be together in a single patch series. You could have sent it as 4 separate patch series. Or if you're updating it every day, a patch series of 30 patches that gets updated every day will be ignored by almost everybody, because they assume you'll send another one tomorrow, and so they ignore it until you stop sending new updates. So yeah, they're often left for another day by reviewers. Finally, be aware that maintainers will leave space for others to review patches. Some maintainers explicitly ignore RFCs and assume that reviewers and other developers will handle it for them, because they are simply too busy to spend time replying to RFCs as well. And that's okay. Not all maintainers do that. Most don't, but RFCs are still worthy techniques to get help. It's the help you're getting is going to come from reviewers and developers, not from maintainers. Resends are useful, in particular, because what you're doing when you send a resend is reminding the maintainer that the previous post didn't get any negative code reviews. Right? So if you're resending it as opposed to sending a version 2, that's saying there has been a relatively long period where there has been no negative feedback. Be very cautious about rushing a resend. A week is the absolute minimum. I would personally never send a resend without 2 weeks elapsing. There is a special case if you're trying to contribute to the ARM kernel. It's documented here. So most code at the moment goes to the ARM sock tree, which follows the classic patch processes. Russell King, who maintains part of the ARM kernel, uses a custom patch tracker. So if you've got Russell King in the 2, you might well find that you need to go to this place here and upload the patches in a special way. Again, the rule of thumb I use for anything involved in this space is if you're getting to the point of resending and Russell King is on copy, go and have a look at the patch tracker and see if you need to send it to the patch tracker instead of resending. And then just some good practice for you. This is different, Daniel, it's not me. Hi, Daniel, here's a patch. Could you consider applying this patch and its documentation for your tree in this? So this is a request from somebody who's written a patch set that's been picked up with the tested bys and acts, and asking maintainer if they'll take it via their tree for this version. And that's perfectly acceptable bit of manners if they've sent the ACK, it's the right person, the patch is separable. You would never do this if this patch was not separable. It's a basic request from the developer to say, this patch can stand on its own atomically. Would you take it rather than picking it up? You can use IRC to poke maintainers. Here's an example of somebody doing it deftly at the bottom. This comes with a huge warning that you should never really use IRC to poke review unless you've already got a really strong relationship with that maintainer. So in this case, a dev and a mate probably already know each other, and even then, it's fairly hands-off. It's could you take a look at this? Otherwise, don't worry, I'll schedule a resend in the next kernel version, and I'll take silence to schedule a reminder. So it's not you must review this, or I need you to review this. And even here, this is probably somebody who has a decent relationship already with the maintainer. However, if you've got maybe 2 kernel cycles and nobody speaks to you, nobody at all, it's quiet. You've done all the things, you've checked with colleagues, you've looked for problems with your submission, the maintainer is unresponsive and probably unresponsive to others as well. If you can get absolutely nothing out of the maintainer, then patches for sorry, let's go back to the other thing. Andrew Morton serves as this maintainer of last resort. And in principle, what that means is when you want to patch unmaintained code in the kernel, you should send them to Andrew for review. And he hoovers up all the spare bits. Likewise, if a maintainer is completely unresponsive, this doesn't mean they're refusing to apply your code. This means they're refusing to give you a review. If you're in that situation, then patches or maintained code could be CC'd or TO'd to Andrew. You probably should put something in the cover letter saying that you've copied Andrew because, and give links to the previous circulations of the patch. You'd usually say, this has been out for review for 10 weeks. I've resent it twice. There has been no negative feedback at any point. Andrew, could you apply it for the next trees? That kind of thing. You know, you're basically having to show when it went out for review that you've got no negative feedback, give links to the mailing list, and explain why you've copied it to Andrew. Sometimes that will shake the maintainer and give them a quick response and say, don't worry, Andrew, I'll handle this. Or if the maintainer doesn't reply, then it's likely Andrew will pick it up. Do not ever rush the maintainer of last resort. It is for the case when a maintainer has essentially disappeared and stopped replying to things. So I'm sorry we're slightly over. I am going to go very briefly through the mailbox subsystem, and then we'll close down. So this is picked because it's a real example of a long and complex upstreaming flow. It is the final example because it is it's the worst case likely example. You don't see this as often these days because the SOC frameworks, the stuff that supports embedded SOCs, has matured enormously over the last 10 years. So while you may still have innovative hardware that has no subsystems, it's much rarer. I think probably the most recent example I can think of will be laptop privacy screens where these kind of effects took place. And it was represented about a year of elapsed time with several different implementations and several implementations and 7 vendors involved. So it's about a mailbox. Oh, sorry, I had a switch. The reason this wasn't a simple process wasn't because the hardware was hard. Mailboxes are trivial, but it was massively fragmented, which is what led to this challenge. So mailbox. There was a plan to add a mailbox IP. Mailbox IPs are very common in SOCs. They are used usually to send messages between heterogeneous coprocessors. They're usually a request to another coprocessor to do a bunch of work and to send the result back when they're done. In the simplest case, they're literally just doorbell interrupts. Sometimes they add things like spin locks and other technologies to work between the two, but they are ultimately messages, ways to message other heterogeneous processes. The reason it's interesting is because generally this followed exactly that pattern where there was a first implementation, which was tucked away somewhere in a driver. And the second implementer came along and somebody realized that these things had something in common and asked them to create a subsystem. So what could have been a localized driver hack got converted to a request to make a subsystem, and that was a much larger task. So that idea of a mailbox is they're simply there to signal between CPUs. This is not the SMP case. The key difference here, well, the reason I say heterogeneous processors, they don't have to be heterogeneous, but they're not in an SMP cluster together. And usually that means CPU2 is a real-time microcontroller of some kind. So they often work in shared memory, and then with this mailbox to pass signals between them. The first implementation of this was written by a TI developer for one of the OMAP platforms, and it became a driver that only worked on OMAP and was tucked away in Arch ARM as a special case. It was upstreamed. It wouldn't have been upstreamed this way these days. So drivers in Arch ARM were something anomaly during the formative years of the ARM kernel. There was the famous Linus feedback in 2011 about how that was a strange way to organize things, and generally things go through drivers now, but there is things like driver sock, which can pick up some of those first implementations and adopt them. So we have the TI OMAP first implementation. And we then had other socks with similar properties. So the original driver was very closely tied to the specific OMAP mailbox design. And a developer from ST was faced with a different mailbox that had similar data flow properties. So it was something you could create a generic driver that supported both OMAP and ST fairly easily from the original OMAP code by bringing it into driver space. So the second implementation was a genericized version of the mailbox driver and specific implementations for both TI and ST. Incidentally, one of the reasons I can use all the company names involved is it's part of the public record. So I'm breaking absolutely no confidentiality when I discuss these with real company names attached to them. So the Fujitsu team, which was it was a team at Linaro responsible for looking after Fujitsu. So it's the Fujitsu landing team. We're watching the progress of those patches on the mailing list, and also had a mission to enable the mailbox. So this is what I've been describing before, the idea that you might sit and observe activity on the mailing list. They observed the activity on the mailing list, and they recognized that the proposed API was not going to be sufficient to support the Fujitsu case because the differences in the hardware were greater on the particular hardware that they were responsible for enabling. So they joined the conversation, they discussed what they saw as the shortcomings of the proposed API, and they gained consensus. They got agreement from the other developers that you could move to a better API that was more generic and more suited to the Fujitsu IP. Now, jumping in early meant they were able to cooperate with the TI and ST developers and get a shared understanding as quickly as possible. It allowed them effectively to deliver their code more quickly. If they hadn't spotted it, it's still the case that you could change the APIs afterwards. If you're interested in the Linux view of stable API, have a look at this. You can perhaps see the prejudice in the stable API nonsense name of the file name. You would still have been able to evolve the APIs later, but it would have been more time consuming because you would have had to arrange for TI and ST to test and things like that. It would be more difficult. And that resulted in a friendly consensual takeover. So the Fujitsu team member rewrote the driver in a couple of days. That covered his objections. He brought the TI and ST developers with him, so they liked that implementation. And there was no, let's keep our version, let's keep our version. All parties agreed to adopt that new version. So that was very much the consensus forming on the mailing list, and it was very commendable. There was no not invented here. There's no protecting their code. People, as far as we're aware, were very happy with the direction taken in the new implementation. So we have this third implementation written by one of our engineers and supporting TIST and Fujitsu Silicon. Over time, that picked up attention. All before this subsystem was delivered to the mainline, other companies with similar needs were picking up on it. And to the extent that by the time the code was accepted into the kernel, it had 6 implementations, which is unusually high. To have that many implementations before something's landed in the kernel was quite high. And we claim that it was only possible because of that extra flexibility. So some of the Samsung, Intel, Broadcom things would not have fitted into the TI and ST original pattern. So that was excellent outcome, all things considered. Unfortunately, one of the problems with developing a new subsystem is how do you find the mailing lists where it's being discussed? And what that resulted is a team at Sony was also chasing a similar problem for some of the socks that were in their phones at the time, I think it's their phones at the time, and posted a generic mailbox implementation different to the other one which we had 6 drivers for. And it came from nowhere in the sense that the teams didn't find each other. It wasn't malice, it wasn't anything like that. It was the fact that without a mailing list to coordinate from, finding each other just hadn't happened at this point. So although several companies had found it, Sony hadn't, and they posted a separate thing, which is very legitimate. It became interesting because Greg KH, who is very influential, observed the Sony patches and supported them. He's saying these are a good way to solve the problem. Just as the Sony developers hadn't seen the work happening in other parts of the kernel, neither had Greg. Everybody filters LKN. And so there had to be some delicate work done to bring Sony and Greg's attention to some of the previous discussions and to try and find consensus on the way forwards. So to some extent, this was in part due to momentum. So the kernel devs had been discussing, they developed a system that was quite flexible and was working well for lots of different mailbox designs. And so they were all pushing to some extent against the Sony design, which they didn't think matched the hardware they had as well, etc., etc. So this was all to do with the joint discussion with all the parties, including Sony. And the result of all that was eventually that after discussion, support switched, and the consensus was eventually reached that the NARA implementation would be adopted. And like I said, the moral here isn't really that, pick the NARA implementation. The moral was all about the consensus building was what made that happen. So eventually the new implementation hit mainline. This is quite a long time back now, so 3.18. And there were a lot of people involved who did very much the right things. There were a lot of people who set their ego aside. All the people who had built one implementation, 4 implementations in total, 3 people's egos had to be set aside to reach consensus at minimum. So there was a great deal of good work in building a consensus, finding the right pattern. It was still a long journey. Like I say, it was still a long journey for all the developers involved to get this far, but that's what they did. So I guess that's the end for today. I apologize for the overrun. I was keeping things at a fairly relaxed pace while we were talking about some of the early parts of mailing lists and kernel versioning. So I hope you've at least enjoyed the extended delivery. So the last thing from me, unless there are questions coming through, are support@lenaro.org if you want anything further from me on this subject or anything else that Lenaro is working on. That's how you can keep in touch as we go forwards. And other than that, thank you very, very much for spending time with me. And I hope it has been useful. I like Zoom flying all these little hands up the screen. I've seen that before. If there are any, okay, somebody's asked about the, so the slides should all be in the shared folder for the course. So if we can post the file server link again, it's, excuse me. It's this link here to get to the slides. And if there are no other comments, questions, or anything else, going once, going twice, going 3 times. In that case, thank you very much for spending time with me. I'm going to have a brief rest before I do it all again this afternoon.